Hi everyone. This week we will be continuing our study of radical equations and radical expressions. And in that process, the first thing we learn is going to be something called rationalization. So what is it? It's a process of rewriting a fraction which has a fraction which has a radical term as one with rational terms. Now rational, remember, is ratio of integers like 1/2 and 3/4, etc. So there is no square roots or cube roots, none of that. Now here's how we're going to do it. If I have 1 over root 2, right, what I can do is if I can somehow write this as 2 over 2 times 1 over root 2, which is fine because 2 over 2 is 1, and rewrite root 2 as, 2 as root 2 times root 2 over 2 times root 2, then this gets cancelled, and now I end up with my denominator being a rational number. Right? So essentially what I've done is I have sent the irrational number from the denominator to the numerator. And so the process for simple fractions like this is you take the denominator and you multiply and divide by the denominator. When you do that, the top part becomes square root of 5 times 6, and the bottom, because these are square roots of the same quantity, it becomes 6 to get you root 30 over 6. So we do the same thing here. The only difference is because it's a cube root, I'm going to split this first. This is cube root of 25, but because it is 25, remember this is 5 squared, which means to get rid of the cube root, I just need one more copy of 5. So I multiply divide by cube root of 5, and at the top I have cube root of 7 times 5, and at the bottom I have cube root of 5 cube, ending up becoming cube root of 35 over 5. So with cube roots, it's slightly different because now I'm actually counting how many 5s I need to multiply by in order to get 3 copies, so that the cube root and the 3 copies cancel each other out to give a resulting 5. Now this particular method can also be extended for when we have variables. So root 3x over root 5y, and that's a square root. And for square root, all I do is I take the denominator and I multiply and divide by a copy of the denominator. Once I do that, right on the top, that just becomes square root of 3x times 5y, and on the denominator, the entire goal was to rewrite the denominator as a rational number, and when I take the square root of the same thing multiplied by itself, it just becomes a 5y, which consequently becomes 15xy in the numerator divided by 5y in the denominator. So what we are achieving here is called, we are making the denominator into a rational number. Okay. Now this process here, this is not solving. We're not solving for anything. This process is just, it's a process of rewriting or simplifying. And because it's a very specific process here, which is that we are making something that is not rational into something that's rational, it's also called rationalization. But to be more specific, it is rationalization of the denominator here. Okay, we cannot make both numerator and denominator rational without changing the value. So that's not possible. So either we can say that given this particular radical expression, I am going to rewrite it so that the numerator is rational, or I can say that I am going to rewrite it such that the denominator is rational. Both cannot be achieved at the same time. Okay, and next moving on to the next level, what happens when there are more than one term? So when there is more than one term, we take motivation from an identity that we have learned before, which is difference of squares. So what is the motivation? The motivation is, if I have sum of two things multiplied by the difference of those two things, then they equal a square minus b square. How do we use this motivation? You use this motivation on radical numbers. So if I have root 7 plus root 5 times root 7 minus root 5, by this identity, this is going to be root 7 squared minus root 5 squared, which is helpful. Why? It's helpful because we know that when you have a radical or square root and then you square it, they cancel each other's actions and you end up with the number inside, which is 7. So this is 7 minus 5, which is 2. So that is where it is useful. It gets rid. So if you can create this kind of a product somehow, then you get rid of the there's no more square roots. So you can see that in general, if you have the sum of the square root of two things and the difference of the square root of two things, then it just ends up becoming square root of a squared minus square root of b squared, which then ends up becoming a minus b. Okay. All right. So now that we have our motivation about as to how this particular square root stuff can be made into a fixed number, and we move on to a definition called conjugate. So how we define conjugate is, we say conjugate of a term root a plus root b is root a minus root b. Or if you have a plus root b, then it's a minus root b. If you have a minus root b, is a plus root b. And so basically, what are we saying? We're saying that if you're given any term, its conjugate is you make the square root part of it negative. And y, the y comes from here. Yeah? Because we are going to use this conjugate stuff in order to rationalize it. So to rationalize the denominator, what we do is we multiply and divide just as before. We multiply and divide by the denominator. Here, instead of multiplying, dividing by the denominator, we want to use this identity, so we multiply and divide by the conjugate of the denominator. Okay, so this becomes 2 plus root 5 over root 6 minus root 3 times root 6 plus root 3 over root 6 plus root 3. Now this, what we multiply divide by, this is actually 1. So that's fine. There's nothing that we are changing over there. So in the numerator, I have 2 plus root 5 times root 6 plus root 3. And on the denominator, I have root 6 minus root 3 times root 6 plus root 3. Now the denominator, the whole point of this process was to write this as this, which makes it a root 6 squared minus a root 3 squared, which is a rational number. And on the numerator side, I am going to FOIL all of these out. And after I FOIL, that's a 2 root 6 plus 2 root 3 plus root 30 plus root 15. Which, let's try to see if there's any simplification that can be done over here. 30 is 6 times 5, so there's no squares there. It's 2 times 3 times 5. That's 3 times 5. So there's not much we can do over here. So So I'm going to leave it as it is. So this is just going to be 2 root 6 plus 2 root 3 plus root 30 plus root 15 divided by, that's going to be 6 minus 3, which gives 2 root 6 plus 2 root 3 plus root 30 plus root 15 over 3. Okay. Now, just here we are going to rationalize the numerator. Now, like I said before, we can only do one of them at a time, right? So it depends on the requirement. Sometimes we want the denominator to look like or to be a rational number. And sometimes we may want the numerator to be a rational number. However, the process doesn't change. The motivation behind the rationalization process doesn't change. So here we are going to multiply and divide by the conjugate of the numerator, right? Because that's the one that we are trying to rationalize. So this becomes a plus h minus root a over h. So if I look at this term, all I have to do is I have to make the same copy, the copy of the same thing, and just replace the minus by a plus. This is root a plus h plus root a. So that on the numerator, now that becomes root of a plus h squared minus root of a squared over h, root of a plus h plus root of a. And the whole motivation or the whole point of doing this was to get rid of the square roots. So that becomes an a plus h minus a on the top over h times a plus h plus root a, which is then h over h times root of a plus h plus root of a, which comes out to 1 over square root of a plus h plus square root of a. So again, keep in mind that this is not solving. This is just a process of simplifying or rewriting an expression in a form that you are somehow or for some reason are interested it being seen in, right? So in this case, we are interested in seeing what this looks like with a rational numerator, not really caring about the denominator. Okay, that's it for this video on rationalization. The next thing that we will learn with radical expressions is how to solve equations that involve radical expressions. Thank you.